All right, so today what we're going to do is we're going to take a look at graphing any quadratic equation, which of course gives you the shape of a parabola when you make the graph. Because the format that you saw last time where you had it solved for y and you had some bracket squared plus some constant, plus or minus some constant, that format is really easy to use, but it's not the way you normally see a quadratic. Normally, you would just see y equals x squared plus bx plus c, right? And you often have a number in front. And so that changes all the rules. Now, we're going to first talk a little bit about what that variable in front, or that coefficient in front of the x squared does, but it's really not that important to you. But you might be asked to describe it in a question. So I do want to talk a little bit about what happens there. So let's just see if we're going to discover it really quickly if you think about it. All right. So when you have the basic shape of a parabola, right? It's always symmetrical, no big deal. They can be wide or they can be narrow. And the thing that makes it wide or narrow is that coefficient in front of your x squared. So, anytime you have that coefficient, remember that means you're multiplying times your x squared, that number times your x squared. So instead of just squaring your x, you're squaring your x and multiplying it times another number. What's that going to do if you multiply it times another number? For example, if I just take 2 and square it, I get what? 4. But if I also multiply it by 2, that turns it into an 8. And so what's going to happen is, instead of 2, 4, I'm going to get 2, 8, which is way higher, right? So what that's going to do is, it's going to make the parabola very skinny, right? It goes up faster, doesn't it? And so it makes it very skinny. Now that's what happens if your a is a whole number. But if your a is a fraction, think about what that's going to do. If you multiply by a fraction, the number doesn't get bigger faster, it gets what? Smaller. So if you take a 2 and you square it, you would get a 4, but then halve it, you would get a 2. So that's going to bring it down some. So what that's going to do is, it's going to make your parabola wider. Okay? Now again, not helpful at all when you're graphing it. Makes no difference. You could learn the pattern. It's just dumb. Don't do it. But you might be asked to describe why it's happening. Why is this parabola wide and this parabola is narrow? Well, the narrow one has a coefficient that's a whole number, which is making your y values get bigger faster, right? And the big wide one will have a coefficient that's a fraction or a decimal, right? They do the same thing, which is making the numbers smaller, so it fans out in smaller increments.
Would you call it the width of the parabola?
Yeah, why not? Yeah, I don't think there's really a technical term for it, but yeah. Okay, so they're going to mention that. You can do some of those exercises if you want to. It really doesn't help you, again, when you're graphing these, but it does help you remember that all the time the merit and excellence questions are about describing what you're seeing, so you might see one of those, and we'll revisit it when we do the revision for this. Okay? So that's the first thing I wanted to talk about. The next thing I wanted to talk about is simply steps to graph any quadratic equation. And again, you're going to see that they're already done some of this work for you, but then they're going to stop. So they like to lead you slowly into it for some reason. It's not really that necessary. Hello. Okay, good morning. All right, so remember that when you're solving a quadratic equation, what is the process that we use to solve a quadratic equation when we looked at those? Do you remember? Starts with an F. It's everybody's favorite. Factorizing, exactly. And that's what we're going to do here. So the first step is always going to be to factorize completely. And remember, I always say completely because we tend to forget the first thing in factorizing, which is look for a GCF, the greatest common factor. Mm-hmm.
Are these parabolas involving that?
No. No. Solving quadratic equations will be on the MCAT, but graphing won't be. Okay? All right. So factorize completely. Now, they could ask you a question about where a line crosses, but that's not the same thing. All right. Now, you're going to notice that in a lot of the ones that we do today, they've already factorized it for you. Don't multiply out the brackets if it's already factorized. Okay? And we looked at some of those when we were solving before. Second, solve to find the zeros. Now again, we've talked about this before, but now we're going to actually use those. And the zeros of an equation are the solutions. So remember what we did was we just set the brackets equal to 0 and then solved, right? You factorized it, then you set each factor equal to 0. Each of those factors, you set them equal to 0 and then solved it, right? So you turn the quadratic into two linear equations, okay? All right. You're going to plot. Okay, then you're going to plot those values on the x-axis because they're x values, right? So you're just there. What they literally mean are the zeros of an equation. They're not the only solutions to the equation. There are an infinite number of solutions to every quadratic equation. These are just two specific equations, solutions that are called the zeros because they're the spots where x equals 0.
They're the x-intercepts, right?
Yes, right, exactly. So they're the x-intercepts. Mm-hmm. Perfect. Okay? So what you have is you have your parabola, and you might get 1 and 5 or something. So you just put those numbers on the x-axis. So those are the x-intercepts. Perfect. Now, many times they'll ask you for the y-intercept as well as another graphing point. And you can find it, and we're going to do that simply because it's an easy point to find. But sometimes it doesn't help you see exactly how far the graph is going to go, but we're going to put that as one of the steps because they're going to ask you for it a lot. So the next step is to find the y-intercept. I think I misspoke just a second ago. Remember, the y-intercept is where, because these zeros are where y equals 0, right? Not where x, and I think I said x. Where x equals 0. So you're simply going to do that by substitution. You're just going to look at your equation, and everywhere there's an x, you're going to put a 0, which is nice because it just makes the x thing go away. Right? Okay? And then solve it for y. And remember, when you have that number, you just plot it on the y-axis, whatever it is. Mm-hmm.
So you take the equation that you
Yeah, so like you have y equals x plus 2 times x minus 1. You're just going to do y equals 0 plus 2 times 0 minus 1, which is 2 times negative 1, which is negative 2. So y equals negative 2. Right? So you just replace those with zeros. And what you're going to see is you're going to do this so frequently that you're not even going to bother with all that. What you're going to do is say y equals 2 times negative 1. Because replacing that with 0 just always makes that go away. Yeah? Does that make sense? Okay. Now, we've got some intercepts up there. What is the most important thing up that I need in order to graph a parabola that you don't see up here? The vertex, exactly. So we need to find it. And there are lots of different ways of finding it. And we're going to talk about a very simple way of finding it. Okay? And it deals with the axis of symmetry, which we talked a little bit about yesterday. Okay? So, step 5. Find the axis of symmetry. And if you'll remember, the axis of symmetry is just that imaginary line that cuts the parabola in half. And if you know the zeros, you know the axis. Because it is exactly halfway between the zeros. Okay. So if your zeros are at 2 and 4, halfway between 2 and 4 is 3. So that's where your axis of symmetry is. Okay? The x value of the axis of symmetry is also the x value of the vertex. That's the point at which the line stops going down and starts going up, or stops, right? It turns on that axis. And so we have our x value by just finding where that, just cutting the parabola in half. Okay? And once you know x, we can then find y by using substitution, right? If you know your x value, you just plug it in and use substitution to find the y. Okay? And that's the last step, or not the last step, actually. Okay. Find the y value. All right, so find the y value by substituting x into the equation. Whoops, that's a terrible x. I'll fix that. X into the equation. So if x was 2, everywhere you see an x, you'd plug in 2. And that'll give you the y value.
Is it the x like the middle point?
Yes, it's the value of the axis of symmetry. Mm-hmm. Plot the... not value. Talking and not listening. Plot the vertex. And finally, draw the parabola. It looks like a lot more than it actually is. It's fairly easy, and it's a pattern. And so once you've done a pattern over and over a few times, it just starts becoming natural to you. Okay? And a lot of it we've talked about before. We've talked about solving these already, so you know how to find the x values. We've talked about the axis of symmetry, so you know that that cuts it in half. We've talked about the y-intercept. That's just the point where x equals 0. So we're just putting pieces together, right? We found the intercepts when we did the linear equations, right? So the same process. You're just going to have different type of graph, okay? So a couple of things here. Finding the axis of symmetry is critical to being able to find the vertex. Shh. All right. Now, it is also going to be one of the keys for solving the application problems that we look at later. So keep in mind every one of these pieces. The reason I've broken them down in the way they are is because you can use these little pieces of information. You're going to be given little tidbits of information when you're solving these applications, and you're going to have to fill in the rest, right? So each little piece of this is very important for you to understand when you're trying to recreate an equation, for example, because you're going to be given some where they give you the graph and then you have to find the equation, right? But that's easy to do as long as you know all the pieces. So we're going to practice a lot of these, and then we'll look at the pieces. All right, so here we go. So this was your last homework. Let's just scroll down to the next one. Here's where they're talking about stretched. Notice there's a 2, and what it does is instead of being wider, it gets narrower, because a 2 makes the x values go higher faster. Here's one that gets wider because it was a fraction. So do you see the parent graph, which is the one where you're just squaring everything, always stays the same width, right? But if you have a fraction in front of it, it gets wider, or a whole number, it gets narrower. It's okay. If you want to know what they do, but you're not going to have to worry about that too much. All right. Now, the first thing they do is they have you complete some tables to graph an equation because remember when we talked about linear equations, completing a table always works, right? But if you're going to complete a table of values, are you guaranteed to find the vertex? No, right? So you're going to have to keep finding values until you find the spot where that thing turns. And that place could be a fraction. And how many of you are going to select on a table with fractions on it? Nobody, right? So it's a lot better to use the other process. But they're going to give you some. And of course, if they give you some with the table, one of those pieces is going to be the vertex. All right? So you just fill it. You just substitute and work them. Remember, you can use a calculator here on these. If you want to use a calculator, your calculator can do this substitution for you, right? Well, of course they can. Can I show you? Do I need to show you how? I will happily show you. So look at y equals 1/4 times x squared. So, oops, sorry. It would help if I... Right? So let's just take a look at this. Draw graphs for the following equations. We have y equals and then 2 brackets. I know this is a quadratic because if I multiply those brackets out, x times x would give me x to the second power, right? So x squared. So that means it would be a quadratic. So we know that the graph that we're looking for is going to be a parabola.
What page is this?
So
41, I think.
43. Yeah. Okay. So since it's a parabola, I need to first find the... All right. So first thing we're going to do is find the x-intercepts. Well, the x-intercepts are simply the places where we're going to set each factor equal to 0. Right? Those intercepts are the solutions that we were finding when we solved a quadratic equation. And in this one, they've all been really nice to you, and it's already factorized. So I don't have to factorize it. I just have to set each one equals to 0. What I'm doing is I'm finding out the places where y equals 0. Right? To solve this one, what do I do to solve x minus 2? Add 2 to both sides, which gives me, x equals 2. So I get positive 2 as my first intercept. Here I'm going to subtract 4, which gives me negative 4. In other words, taking the number away from the x changes its sign. That should look very familiar to you, right? So I've got x-intercepts of positive 2 and negative 4. Be careful with your signs. Then I'm going to find the y-intercept. And again, the y-intercept simply gives us an additional point to be able to graph so we can see how wide or how narrow the parabola is going to be. In reality, the x-intercepts is plenty. Right? But we're also going to use the y-intercept to answer questions. So you need to be familiar with using it. So it's really superfluous to graphing the parabola, but it's not. And remember that anything that they do here, they're doing because it's NCEA type questions might come from this kind of information. Okay? So to find the x-intercept, that's simply the places, the y-intercept, that's simply the places where x equals what? 0. So if x equals 0, that means that's gone and that's gone. So it's just negative 2 times positive 4, which is negative 8. Right? If x equals 0, it just makes it go away. So just mark it off and multiply the two numbers together. Then we need the axis of symmetry. In order to find that, I need to know my intercepts, where they are. So go ahead and just plot them. Now, you can also just use subtraction. You can find the distance between them and divide by 2, but most people find it easier just to count. So I've got a positive 2 and a negative 4. So that's 1, 2, 3, 4, 5, 6 units. So that means that my axis of symmetry is going to be 3 units between them, right? They're 6 units apart, so that means 3 units. Okay, so not at 3, but 3 units. Draw my dotted line for my axis of symmetry. They'll want to see it. Right? So draw the line. And that's where x equals what? Negative 1. Excellent. And now we can find our turning point by using that negative 1. So it's just y equals, everywhere there's an x, I'm going to put that turning point of negative 1. Do you see that? I'm just taking the original equation and plugging in that -1 everywhere there was an x. Yeah? So now, just do the math. Y equals, what's -1 minus 2? -3. -1 plus 4 is +3. And -3 times +3 is -9, which is way down here. Okay? So let me change the color so you can see the points better. Right? So I have x-intercepts there. I have the vertex there. Oops, I forgot to put the y-intercept. It's right there. So do you see that it really doesn't tell us much? But, again, be familiar with it. Now that I have those points, just draw your line. Okay. So it's mainly substitution after it's factorized. And these are factorized for you, but that's not always going to be the case. Okay? Now, you do have to practice this some because that's a lot of steps and it's a lot of pieces. They're not hard, but you need to know where all that stuff is coming from, right? You can't be fuzzy on these because, it's, like I said, they're going to give you applications where they're just going to give you a picture of a scenario and you have to come up with the equation of a line based on that scenario. Then they're going to say, now we're going to put a swing on this rope. So now I need to find the places where that swing is cutting across the x-axis or cutting across the parabola. They're not difficult if you're really comfortable with every one of these pieces. Did you have a guess? Okay.
So what test will this be on?
Tables, equations, and graphs.
What is that?
We'll look up in a minute and see.
We have it soon.
No, it's next term. I just don't know. Yeah. So you get a little time. Okay? All right, guys. So let's just look at another one. What I want to do is just look, see what else. What do I know about this one because it has the minus? No, don't bother distributing it. Just use it to remember. Yeah. Now, when we do find those values, however, we need to use the minus. Let's just go through this one really quickly. Okay? So, green is for color math. Now, the x-intercepts, now does that minus affect the intercepts? No. Remember, the intercepts are just those things inside. And all you have to do is remember, you pull it away from the x, it's going to change the sign. So do I need to show all that work? Nope. What are my intercepts? -2 and +4.
Wow.
Right? So you don't have to show it all if you don't need to. The y-intercept is where these are zeros. Now this one, which makes those go away. Now that negative does come into play. Because if I multiply 2 times -4, I get -8. But what's that negative going to do to my -8?
Positive 8.
There you go. So it does come into play when you're finding the other pieces. Anytime you do the substitution, that negative is going to have some value. Okay? So now, at -2 and +4, let me just go ahead and switch to a different color. So -2 and +4 are there. So that's 1, 2, 3, 4, 5, 6 units. So that means that my halfway point is at 3 units. So that gives me an axis of symmetry at x equals what?
1.
+1. There you go. Good. Okay. Now I'm just going to substitute that into the equation to find my y value. So y equals negative. Let me erase that because I can't see what I've done. 1 plus 2 times 1 minus 4, which is -3 times -3. So 3 times -3 is -9, but that minus is going to turn it into a +9. There you go. Okay. So that means up here I get my point. That's my vertex. Right?
Oh, so it's a downward.
Yes, because of that. We knew that minus was there. Okay, so we're just going to draw our parabola. Okay, I'm okay with that. If you need to get it out of your system, go ahead. No big deal. Y'all are good students. Okay, so the y value for the turning point is at 9. Now, they're asking you for some extra points. Choose any extra points you want to, but I'm never going to ask that. Okay? Now, yeah. And the reason they're asking for extra points and reflections, so that means there's an extra point right here, right? And its reflection is across the axis of symmetry exactly that many units. So don't get hung up on that word reflection. It just means what's the reflected point on the other side of the parabola. Right? So if you have a point here, right, that's 3 units away, then that means there's another point here that's 3 units away. Find a point on this side and what would be its reflection.
Why would they even write that? Isn't that just like a given?
Because you might use it later. For example, if I know that this point is something and I want to find this point, then I need to know that it's a reflection of this point, right? So know the terminology. They don't do anything that won't lead to something. Here we go. So let's look at some more of these, just so we can look at them without all the, because there we have our training wheels on. Let's look at some there they don't give us any information, like here and here. So here we go. This one, for some reason, it's easier. It's actually easier than the others, but for some reason, this is one where students freak. Okay? Because there's only one in a bracket. Exactly. Okay? But you know what to do. You know what to do in that scenario. We just put negative 2x equals 0, and x minus 4 equals 0. And if you solve that, negative 2, remember, if you don't have a plus or a minus, you just have a coefficient. When you set it equal to 0, it always turns into what? 0. Right? So you don't have to show solving it. I just showed solving it so you could see it. But if you know it's just some number times your x.
Oh, because it has to times that number to make 0.
Exactly. So it has to be 0. Yeah. Okay? Now, and then this one, x minus 4, you just change the sign and get positive 4. So my 2 intercepts are 0 and 4. Now, you show as much or as little work as you need to. If you want to show solving those quadratic equations every time, that's no problem at all. Okay? All right, so let's graph those. So we have 0 and we have 4, right? Okay? Now, our axis of symmetry, so these are our x-intercepts. The axis of symmetry is next, and that's just halfway between them. What number is halfway between them? 2. I always like to find that next. They find the y-intercepts typically, but who cares? All right, so that's at positive 2. Our y-intercept is where x equals 0. Well, if that equals 0, it's gone, which just leaves me what? Negative 4.
That makes no sense to me.
Oh, come on. Yeah, because if at the y-intercept, the x is 0. In anything, so it means any term that has an x in it is simply going to go. Right? You're substituting. Exactly. Okay? So that gives us an intercept of negative 4, a y-intercept of negative 4, which is down here somewhere.
But that doesn't work, because that's not a problem.
That does not work. What happened?
Negative 4 is there.
Yeah, it's negative 4 and negative 2.
This feels weird.
No.
What did I do? Hold on. All right. So negative 2x became 0. Shh, ladies. And 0 times anything is going to give you 0. Don't take too many shortcuts. I'm making myself crazy. No, it's 0. Which we already had. Right? Because, all right, let me walk you through it again. So y equals negative 2x times x minus 4. If you replace all of those with zeros, you've got a multiple of 0, so that automatically makes everything turn into 0.
So where do we find the best?
What?
Anytime you multiply with 0, so this multiplier of x turned into a 0, and anytime you multiply with 0, you get 0.
Mr. Self, would we be wrong if we didn't take the line of the graph and just stop at the point? We get on.
You got to show the graph. That's the answer.
No. But like, if we did just...
All right, shh, guys. Hello. All right, now, so we need to find the vertex. Well, I already know that the x value of the vertex is where the is where the axis of symmetry is, right? So that's 2. So it is going to be y equals negative 2 times 2 times 2 minus 4. Everywhere there was an x in my original equation, I replaced it with the positive 2 from the axis of symmetry.
So you don't replace it with the 0?
Well, no, that was when we were finding the intercept. Now we're finding the x value. We're finding the y value of the vertex. So we're going to replace twice. Once with 0, and the next time with the value for that axis of symmetry. Okay? Now, doing our math, we get negative 2 times 2 times another negative 2. 2 times 2 times 2 is 8. Negative times a negative is a positive. Right?
But one of them's a positive, so it's like a negative times a positive.
Yeah, that doesn't matter. Does it? Anytime, if you have an even number of negatives, it's all your product is always going to be positive. Right? You can work it out if you want to. Okay, so that gives us a vertex. And listen, guys, if you don't spell out what the vertex is, you're going to end up in some trouble. So the vertex is 2, 8. Make sure that that value is somewhere in your working because they will be looking for it. So 2, 8 is up there. And this one's opening down. And I knew that. Why?
Because there's a negative on the outside.
You bet. Oops. That should be an eraser. Yeah, because that's a negative. So let's just look at this one. So what's going to happen when I set this equal to 0 to find my x-intercepts? I'm going to get exactly the same number. So instead of x-intercepts, plural, I'm going to get x-intercept, singular. Exactly. Which tells you that it hits the x-axis and bounces right off of it. So if you only get one x-intercept, that is also the vertex. Okay? So 5 halves is, what is that, 2.5? So right there. So that means that is not only our x-intercept, it's our vertex. So so you like it when that happens. So that means that if you find the y-intercept, that'll be enough to be able to graph this. We don't have to find the vertex. We already know what it is. Okay? You just have to remember, does it open up or open down? So you'll know which way to draw the graph. This one's all positive, so it opens up. Okay? All right. So that's a kind of a special case. And that only happens if you have one intercept. Now, I guarantee you're going to see a question like that. So, but they may just say that the only x-intercept is whatever. What does that mean for your graph? If there's only one x-intercept, that means that that point also has to be the vertex, right? Okay, because it hits the axis and goes up. There's no 2 points where it crosses, right? So the vertex can't be anywhere else. Otherwise, it would have 2. Okay. All right, there we go. So now we'll do an assignment.